Yeah, I'm currently at UCSF. I build AI systems for medical scanners, so talk to me later about that. But I mostly want to talk about how I got to this point. So, about 10 years ago, I was an astronomer using the biggest radio telescope in the world to study black holes, but slowly becoming one, right? Because everyone in my family is like 350 pounds, and that drove me crazy growing up. And I wanted to know more about why I have this regrettable composition. I took a couple of years after that and did some hacker stuff, mostly studying computer viruses. That'll come relevant later. But suffice it to say, I got my name from my former astronomy career, and I got my hair color from my former hacker career. Neither of them were fun enough. So I went to grad school and did a PhD. That's not the... There we go. Went to grad school, did a PhD, got a PhD in molecular biology and bioinformatics, studying diabetes and obesity. And our lab specifically focused on mitochondria, which I'm not going to tell you about because you already know everything about mitochondria. So after my PhD studies, I had learned a lot about metabolic syndrome, but still wasn't really satisfied in the answer that I found for myself, like what makes me different. So thinking about how you study software and reverse engineer it, I turned to the science of genomics to pursue that answer even further. So I got my 23andMe done, like I'm sure a lot of you did. And that was a very interesting experience because it said, oh yeah, you're about average for your weight. You know, eat right and exercise and all that other boring stuff that isn't really true. So here's the problem with genotyping. Genotyping, which is the technology used by companies like 23andMe, doesn't really look at that much of the genome. So here's a zoomed-in arbitrary gene in the genome, and you've got about 1 million bases of sequence down here on the x-axis. But a typical genotyping chip that measures SNPs in your genome, it's only going to look at a handful of markers, right? So you've got 6 billion letters in your genome, but your typical chip from 23andMe only looks at 600,000 markers. And the markers that they're looking at are the really common ones that most people have that are different. So what if you've got something rare in here that's never been seen before, right? That's the problem. So genotyping technology is great for science because if you do this on hundreds of thousands of people, you can learn about diseases, but it's not really useful for you. None of this common marker stuff is really predictive of what's going to happen to your health. So every single time your cells are copied, this little enzyme called the polymerase does the copying of your entire genome, and it makes errors all the time. And because of this error process, every single one of you has, on average, about 100 mutations that have literally never before existed on the planet.